All right, so chapter 9, we are going to talk about another very commonly used statistical analysis method called hypothesis testing. So, just to give you a brief idea about what this test is about, let's first talk about what is a hypothesis. So in this context, in statistics, a hypothesis is a statement, a concern, a claim about a parameter. So for example, it can be a statement about population mean. It can be a statement about population proportion. So any statement, claim, we'll use different words, concern about a parameter, such as population mean, or population proportion. So the reason we call it a hypothesis is because we don't know if it's actually true. So if it's a statement about the population mean, we don't know if it's true because usually population mean is unknown, right? If you want to actually test that statement, we may have to reach out to the entire population and get the information, right? And we cannot usually do that. So any hypothesis is always about the parameter. It never be about a sample value. You cannot build a hypothesis about sample mean because sample mean is a known number. So it's not going to be hypothetical statement. So to give you some examples, just to get the idea clear. So some examples of hypotheses could be a manager, a factory manager. Manager would be concerned. Is concerned about that the average weight of a package, say of a candy bar, let's say they produce candy bars, and the manager is concerned that the average weight of a candy bar is more than the amount advertised. More than, let's say their candy bars, they advertise it's weighing 250 grams. So the manager is concerned that it's more than that due to some machinery problems, due to any problem in the process of making it. He is concerned the final candy bar comes out as more than 250 grams. So when you look back into read again, so manager is concerned that average weight, so that's your parameter, that's the population mean. So he's not just talking about a batch of 20 candy bars, he's talking about the entire production. So if you think of the entire production over the past years, the average weight, so that's what he's talking about. So average weight is more than 250. So that is his concern. Hence, it is the hypothesis. So if you build a hypothesis here, so mu, population mean, is average weight of a candy bar. for this factory. And the hypothesis is actually mean is more than 250. So what the hypothesis test is going to do is it's going to collect a sample, study the sample, and then see if this is a valid concern. So we are going to answer the manager. We are going to run the test and say, okay, hey, you don't need to worry. This is not a valid concern. According to our hypothesis test, the average weight is not actually more than 250. So don't worry about it. You can continue with the production. Or else, the other way, if you run the hypothesis test and the result came the other way, then you have to tell the manager, okay, so this is what we have found based on our sample. It seems like the average weight is more than 250. Your concern is valid. So you may have to go through your production process and then figure out what is going on, what is the problem. Okay, and to give you another example, let's say the proportion of graduates, or we can say rate of graduates, if in college A. So let me add something more. The dean claims that the proportion of graduates in college A is 75%. So the dean claims a certain college, because colleges often do these kind of advertising, right? Because they want to recruit more and more students into their college. So they claim about we have a higher graduating rate, we have a higher employment rate. So those numbers, when you look into colleges' websites, you will always you see these kind of numbers, right? So what is the base of this statement? So is this actually true? We don't know, because this talks about the population proportion, right? So this talks about the proportion of all graduates so far from this college. So it's like out of everybody enrolled in this college so far, how many graduated. So that's this value is about. So if you want to validate this exactly, you would have to contact all those who enrolled so far into this college, right? Which is impossible. So we are going to run a hypothesis test and see if Dean's claim is true. So when you build the hypothesis, you need to identify the parameter. So your parameter is the proportion, and proportion is, and then the connection. Proportion compared to what? So proportion is 75%. So your parameter is proportion, population proportion, simple P, and simple P specify according to the question. So according to the question, it's the proportion of graduates from college A. Okay, and the hypothesis is proportion is 75%. There you go. Okay. So in a question, when you have to run a hypothesis test, your first job is to do this part. You have to identify the parameter of interest, and then you have to build the hypothesis. So you have to basically build this one on your own. Okay, so actually this is actually the first step of conducting hypothesis test. Identifying the hypothesis. What is the hypothesis that I'm trying to validate using a hypothesis test? Okay, right, so we are going to do more practice in worksheet on building this part, and then let's talk about what are the steps of conducting a hypothesis test. So those we do have 5 steps of conducting a hypothesis test regardless of the parameter of interest. So for population mean or population proportion, you would have to go through these 5 steps. So 5-step process. Of hypothesis test. So step 1, state the hypothesis. So the reason I'm using plural, it's not just, it's going to be in 2 hypotheses actually. It's not going to be 1 hypothesis. It's going to be 2, one versus other. So we are going to test one versus another. So the 2 are called H naught versus H1. So H naught is the null hypothesis. It's called null hypothesis, and H1 is called the alternative. Hypothesis. So we are testing one versus the other. So the null hypothesis, the way we identify that the statement is a null hypothesis is that in the hypothesis, when you build it, if you happen to have the equal sign in it, it is called a null hypothesis. The statement has equal sign in it. So if the statement has equal sign, less than or equal sign, greater than or equal sign, these 3, one of these 3, it's a null hypothesis. So then the complete opposite of it is the alternative. So if the statement has not equal sign or less than sign or greater than sign, then it's called an alternative. So if I go back to those 2 that we built up here, so factory manager is concerned that the average weight of a candy bar is more than, so the sign is greater than, this is what we have, right? So greater than means this is an alternative. And over here, Dean claims that the proportion of graduates in college A is 75, so equal sign. So that is a null hypothesis. So this is how you write null hypothesis. H naught equals to P is 75%, and that the other one was an alternative, right? H1 is mu more than 250. And the other thing you need to know is that once you figure out, okay, so the given statement in the question is a null. So in our first example about the average weight of a candy bar, so we figured out that it's an alternative, right? Because the sign is greater than sign, more than 250. So once you figure out that it's an alternative, you have to build its corresponding null. So if this is an alternative, your corresponding null should be the complete opposite of it, mean less than or equals to 250. So this is your step one. So in conducting a hypothesis test, you need to read the question, figure out whether the given statement is null or alternative. If it's null, you build the alternative on your own. If it's alternative, you build the null on your own. So in the test, we are testing one against the other. So at the end of the test, we are going to accept one or the other side, right? And for this one, so for this example, proportion is 75%. So this is what the question gives us, right? So question gives us the null hypothesis. So then it's your job to build the corresponding alternative. So if it's equal sign, the complete opposite is not equals 0.75. So this is step one for this question. So you can see you have to build the two sides. Only one will be given in the question. So only one side will be given in the question. You have to identify whether it's H1 or H0, and based on that you have to build the other side of step one. So step one, once again, state the hypothesis H1 H0 versus H1. So to maintain the consistency, we always start from H0. We always write down the null hypothesis. P equals to 0.75 versus H1. So step one for this particular question, this is your step one, is proportion not equals to 0.75. And for the other one, H0 is mu less than or equals to 50 versus H1 mu greater than equals to 250. So this is the complete step one, and I must emphasize it is a must during final exams. It is a must that you write down the null and the alternative. If you don't write down the null and the alternative at the end of the test, if you're saying, okay, reject the null hypothesis, if you don't give me the null hypothesis, how do I know what it means by rejecting null hypothesis, right? So it's important, it's utmost important that you write down the first step, H0 versus H1, clearly. So if you don't like to stick to notations, you can write down this in words. You can say, so for this one, H0 is a proportion of graduates in college A is 75%. That's your null. Versus, or your alternative is proportion of grads in college A is not 75%. So either ways are fine. Whether you like the notations, you don't like the notations, it doesn't matter. You can build the null and the alternative either ways. So for this one, H0 is average weight of a candy bar is less than or equals to 250 gram versus H1 is average weight of a candy bar is more than 250. So whichever method you like, you have to build H0 versus H1. So that is step one. And then step 2 is to calculate a value called test statistic. So calculate test statistic. So this value will be calculated using MegaStat. And again, for population mean, if you're running a hypothesis test for population mean, again you have to make that selection a z versus t value. Remember from confidence intervals, we used a z value. Excuse me. We used a z value if you have population standard deviation. We use t value if you have sample standard deviation. Sorry. So same thing goes here as well. So either ways, this test statistic is just a value we calculate using our sample information. Let me add a note here. So for hypothesis test for population mean, mu, test statistic would be a z value if sigma known, population standard deviation, is given in the question, and it's going to be a t value if a sample standard deviation s is given. So here sigma means population standard deviation and s stands for sample standard deviation. Actually, population standard deviation is also a parameter because it's a number related to the population, right? But sometimes in statistics we do have ways to acquire that number accurately. So when that happens, you will have the parameter value. So population standard deviation will be given. So if that's given, you can use the Z approach. If it's not given, if there's no way for us to accurately acquire the population standard deviation, then we use the sample standard deviation. In that case, we are using the T approach. And for hypothesis test for proportion, we don't have to make that choice. It's always a Z value. Okay. And then step 3. Oops. Three of the test is to decide the level of significance. So these are all new terms for you guys. So the notation of significance level is alpha. Alpha. So this is a probability. This is a probability value or a likelihood. So always, you know that this test statistic that we calculate in step 2 is a sample value because we use sample mean, standard deviation, sample size to calculate this number. So we are going to make our conclusion about the population mean based on our sample. So there's a chance of something error. So there's a chance that we may make a mistake. So significance level is the bar, the amount that we are willing to tolerate. So same idea as we had in confidence intervals. So we when we had 95% confidence level in confidence intervals, we were willing to tolerate 5% of error, right? Same thing goes here. So you need to decide what's the level of error that you want to tolerate. So if you choose alpha to be, so always the error rate must be lower, right? So if alpha to be 5%, that means 0.05. The idea of this number is the error rate that we are willing to tolerate is 5%, or the chance, the likelihood we are willing to tolerate by using a sample is 5%. So that means there's 5% chance that you make a wrong conclusion. So I'm only willing to tolerate a 5% chance. That's the idea. Okay, so this number usually given in the question. Usually given value. If not given in the question, always use 0.05 because we need this number later on to make the conclusion. So if it's not given in the question, you can always take 0.05 because that's the most commonly used significance level. That's the most commonly used error tolerance rate. Okay, and step 4, again we are going back to another calculation. Calculate a value called p-value. Okay, so again this will be done through megastat, so I'm not going into details. I will just explain what it means. So the p-value, so we know alpha significance level is the level that we are willing to tolerate. So this alpha is a theoretical probability. So theoretically speaking, I'm willing to tolerate 5% of error. That's what alpha is about. And p-value is the actual error that we are going to make based on our sample. So this is actually observed probability. This is an observed probability of making a mistake. So p-value, the observed probability, likelihood of making a wrong conclusion calculated using the sample. So alpha, we pick the number, we set the bar. Okay, our tolerance is 5%. And then p-value, we actually calculate what is it going to be, what is the actual rate is going to be based on my sample. Okay, so p-value will be different from one person to another. So if I'm using one sample and I have a p-value, and if somebody else uses a different sample, they are going to get a different p-value. So their error rate, their actual error is different than mine. So if your sample is a really bad sample, your error rate, your p-value will be higher. If my sample is a really good sample, my error rate, observed one, will be lower. Okay, and then the last step, step 5, is to compare. So step 5, what we do is we make the conclusion. So the conclusion goes this way. So if the p-value, your observed error based on your sample, is higher, more than alpha, your bar, your set limit. We reject H naught. Whatever stated in H naught, we are going to reject it, which implies, since we are testing H naught versus H1, this implies go ahead and accept H1. Whatever stated in H1 is the true statement. On the other hand, if your error rate, the error rate you observed is lesser rate than your bar, we do not reject the null. Okay, so to maintain the consistency, we always write down the conclusion in terms of H naught, but you need to understand what this means is you have to reject H1. So this is all written in statistical terminology, right? So if you're running a hypothesis test, if you're running it for an industrial purpose, you may have to convert this into words, because the people who needs this result may not understand the statistical terminology. So what it means by rejecting H naught, so you will have to go back to, so if I scroll up to those examples we did, you will have to go up here. So once you decide, okay, I'm going to reject H naught. So for the first one, so reject H naught. So for it, just assume, right? I don't know for this particular example whether it's which one, but just assume that after running the test, we decided to reject H naught. Okay, that was the conclusion. So what does that mean? So that means we are going to reject this statement. Proportion of graduates in college A is 75%. We are going to say that this is a false statement. This is not true. So rejecting H naught means you are accepting H1. So that means we don't know whether it's higher than 75% or lower than 75%, because our H1 says it is not 75%. So we are going to say the dean's claim is not valid. It is not 75%. So that real life explanation is a must. You cannot stop your hypothesis test by simply saying we reject H naught. You have to explain what it means according to your question. So that would be the complete test. So you have to interpret your conclusion. So that's the proper end to a hypothesis test. So we have 5 steps, right? Oops. Undo. So we have 5 steps. Going back to the very first one, let's review. So step 1, state the hypothesis H naught versus H1. And then step 2, calculate the test statistic. This will be calculated through Megastat. But for hypothesis test for population mean, you need to make the choice between Z and T based on the standard deviation. And then we decide the level of significance usually given alpha. If it's not given, you always use 0.05. And then step 4, calculate the actual rate of error using the sample. So again, we calculate it using Megastat. And then we compare the p-value to alpha, the set error rate. So observed probability versus the theoretical probability. So if p-value is, I think I made a mistake here. I think p-value is less than, I think, yeah. So I'm sorry guys, the comparison should be the other way around. P-value is less than or equals to alpha, we reject H naught. P-value is greater than alpha, we do not reject H naught. So please keep in mind, please make that note, correct your notes. If p-value is less than or equals to alpha, we reject H naught. If p-value is greater than alpha, we do not reject H naught. Okay. And then based on your conclusion, you have to interpret, you have to convert it into real life words, right? Yeah, so that's the complete 5-step process of conducting a hypothesis test. And I'm going to show you using Megastat. I'm going to show you how to do run this in Megastat in my next video when I go through the worksheet. So this is your lesson 1 for chapter 9. So I want you to go through it, make yourself familiarized with the steps, and then once you're done, you have to work on the practice session.